What's my guy turning black? Oh.
This scene made me ask myself one question. Why did he not understand something that I thought was obvious? If this clip itself seemed like nothing special, you would be right. But for me, it revealed a chain of problems in my game. And in this video, I'll be explaining my process on how I fixed each of them. For extra context, this is Veks, a childhood friend of mine, who offered to playtest my game, Boxes and Bullets. However, while playtesting, he did not understand that the black flash was meant to indicate a cooldown whenever he used the blocking mechanic. To be perfectly fair, he missed a few obvious cues.
Okay. Is there a boss health bar now?
But to his credit, he did see the health bar. Eventually. Even then, how could anyone, apart from me, tell that this flash was a visual indicator for the block mechanic? And that led me back to the drawing board. I had to come up with a clear way that a player could understand the cooldowns of the block mechanic. Which is when I thought about a cooldown bar. It makes perfect sense after all. A cooldown bar would easily tell the player how much time they could use the block, and how much time they would have to wait before they could use it again. But before I begin making new mechanics, I like to do as much planning as possible before, jumping ahead and trying things out. And that starts with breaking down the mechanic into the simplest component possible. In this case, a cooldown bar only needs two things, a visual and a timer. For the visual, I made a sprite that is 510 pixels wide with this color. There is quite literally no significance to this, apart from the fact that I like this color. The timer, though, already existed, so here's how it works. From 0 to 5 seconds, the player can use the block mechanic. Then, from 6 to 10 seconds, the block is on a locked cooldown, before the timer restarts. Having the components themselves was not enough, because the real challenge was making the visual change based on the timer. So, to figure this all out, I decided to model the timer and the visual with sticky notes. Because our timer is 5 seconds, let's use 5 sticky notes. Each of these sticky notes show how much the visual's width will increase or decrease per second. For example, if our total width of the visual is 510 pixels, then each sticky note would represent 102 pixels. With that, we can make a basic linear equation. The total width of the bar divided by the total timer length multiplied by the total timer length minus the number of seconds elapsed. Basically, if we use this equation, then by the time the timer is at 5 seconds, all of the sticky notes would be gone. And to make this make a bit more sense, essentially the total width divided by the total timer length is the sticky note, the width that the visual changes per second. And all we have to do is multiply that with how much time has passed to get our final width. However, this does lead to another problem. If we use our current equation as it is right now, from 6 to 10 seconds, the locked cooldown, the width of the bar becomes negative. That means we need another equation for the locked cooldown. If we go back to the sticky note model, when the timer reaches 6 seconds, we need one sticky note, which means we need to subtract 5 from however much time has elapsed. With these two equations for our timers, the visual cooldown bar finally worked. But do you really think that's enough? I mean, look at the runtime of this video. There were still a few more problems I had to address, specifically movement and attacks. For movement, I made a dodge mechanic, which I thought could be helpful in avoiding fire damage here, or going under platforms for other levels. But the current problems with the dodge are for both the animation as well as the technical aspects. I decided to focus on animation first, because the current animation was very jarring, and I also wanted to experiment with smear frames. Smear frames are basically a type of animation frame used to simulate motion blurs with exaggerated speeds. When I was trying to think of an in-between frame for the start and end frames for the dodge, I kept imagining cellular division, which seems really odd at first, but then I thought, this is great inspiration for my game. With the animation done, now I had to work on the technical aspect of the dodge. which was making it work under platforms. The current issue was that the dodge relies on a timer which automatically resets after a few seconds, leading to this. But if the dodge's timer was paused while under the platform, then this issue could be fixed, which led me to a potential idea. What if I could make these platform areas locked unless the player was dodging? Expanding from that idea, I made these invisible pink areas which could pause the timer. Unfortunately though, the pink gates weren't really working. Even while the player was in other states like walking or flipping, it could still enter the pink gate, even though it was only supposed to work when the player was dodging. To solve this mystery as to why this did not work, I set up a test chamber involving different cases. Case 1, any scenario involving dodging before interacting with the gate. Case 2, not dodging while not interacting with the pink. Case 3, after dodging with the pink. And Case 4, dodging while touching the pink. And with that, the problem will reveal itself. Case 1. That basically confirms there is an issue with the way the states are managed. Specifically, the Boolean logic in my movement system. You see, my current movement system uses a series of Booleans, which are basically just true or false. For example, the Boolean can walk has to be true before the player can walk. After fixing these Booleans, I made sure that can dodge would not be set to true while the other states happened. And once I did that, everything else worked. As of now, I've managed to solve the visual indicators and rework the dodge mechanic. But there was still one crucial issue left, especially with Veks' boss fight. Attacks. Right now, the boss fight was stale because there was only one way to attack the boss. But this isn't just limited to the boss fight itself, this is a problem I've had in my game for a while. Shooting is the only way to attack enemies or interact with the environment, which I think is a problem because that can get very repetitive. But unlike the last two problems, making a new attack entirely from scratch is much harder. Especially this one. A type of attack that could work in all directions. If this worked, it opened the possibility to new bosses, levels, enemies, and much more. First, I decided to plan it all out and break it into various components, like I did with the block cooldown bar. So, the next step is going to be making something which I call the head cannon. The way it works is the player, right here, is going to get its head into the cannon and then launch it. Next, I decided to make very basic placeholders, introducing this very friendly character from the previous devlog. In my mind, making something that works matters more than any kind of polish. In this case, I wanted to make sure that the player could enter a separate state, which would then become the headcanon later on. And now that I managed to create a specific state for the headcanon, it was time to make the cannon itself. Now there are a lot of things we have to consider with this kind of mechanic. First, we have to consider the range of the attack. And in this case, I wanted the range to be 180 degrees. You could shoot perfectly left, perfectly right, and it would have this full degree range. So we would have to make it so that the cannon, or the head cannon in this case, would rotate across this arc positioned by the mouse cursor. So you'd make the cannon face the mouse cursor, and the range would be limited right here. So this is where it cannot go past, and it would also not be able to go past this point. There is a bit of a challenge in making the cannon point towards the mouse cursor, and the cannon is still in its idle animation, so when the time comes, I knew I would have to make a separate animation for the cannon. Now, this is where I deviated from my original plan. I decided to allow the player to shoot their head within a full 360 degree range because I considered future levels where a player may have to shoot at a downward angle. This would not exactly be allowed with that 180-degree limit, so I think this was a good change. Regardless of the angle change, nothing seemed to stop these weird errors from happening, and, sometimes changes can cause more errors. So when that happens, I revert back to an earlier prototype of the mechanic. More importantly, with a placeholder state, a defined range, and angle-based shooting from the mouse cursor, I decided to add in a projectile. And this friendly guy will make a perfect placeholder when I replace it with the player's head later on. While the basic principle works, the angle was always slightly off, which took some trial and error to fix. For me, I like to use my development journal to take different notes of the angles, tests, and which one looked the best. Obviously, nothing was smooth sailing. I had fun errors like this. Honestly, I still don't really know how that happened, nor am I going to figure that out. Unfortunately, we do have to say goodbye to these amazing placeholders, and replace them with actual animation. I am notably artistically limited, but I still wanted the character to have more character in the animation. I did this by having their head roll down the cannon and do a little bounce before entering the headcanon state. Another thing I realized after making the actual animations was that I would need a separate release animation, which is something that I really did not originally plan out. But with all of that, I had finally managed to make the headcanon. Because I wanted to work on more attacks from the player, I thought about something called a cannon flip smack. If you're wondering what that is, basically I wanted the player to have a new way of attacking enemies and bosses, especially since shooting can get repetitive. However, this mechanic is very different. The animation has to be made first because the entire premise of the mechanic was that the player would wind up the cannon behind them and deliver a nice, well-timed smack. Now, the problem with making this is that it would create the illusion of death by having the cannon travel through a 3D space. I've covered the challenges of remaking 3D scenes in 2D before, especially when 3D scenes have multiple angles, making it harder to transcribe in a 2D animation. So when I was experimenting with what could work, I realized that rectangles would not convey the kind of death I was aiming for. And this is when I came up with a good reference: index cards. I took a toothpick and taped it to an index card to rotate it and get this reference. And that seemed to work really well. Overall, the process that I use to solve problems in game development relies mostly on breaking down these problems into something smaller. From there, I can model out real-world references, plan out ideas on how to address them, and use a mostly iterative process to eventually fix these issues. While there are many ways to approach problems in game development, this is what works best for me.